Hey students, welcome back. I'm going to do Module 3, Topic 6, Proving Angle Relationships in this video. We're on page 6 of the Week 6 packet. This topic also uses standard GR 1.1, prove relationships and theorems about lines and angles, solve mathematical and real-world problems involving postulates, relationships, and theorems of lines and angles. The objective for this topic is you guys are going to prove theorems about angles, and the essential question is, why is it important to know how to use right angle theorems? Let's get this up for the bell ringer. Alright, so segment addition postulate. Enter selections from the list below to complete the proof. So let's see what we have here. So our given is that GH and FE are congruent. Okay. And that HD and ED are congruent. Okay, so your greens are congruent, your reds are congruent. I like to do these up front because it kind of helps you flow through the proof. So number one, GH is congruent to FE and HD is congruent to ED. And that was given. Number two, we have GH to FE is congruent, and then GH is equal to FE. HD was congruent to ED, HD is equal to ED. Whenever we see we're going from congruent to equals or equals to congruent, it's always the definition of congruence. Because the definition of congruence is, I hope you guys said equals. Equals and congruence. Equals is for numbers, congruence is for shapes. I meant to write that in red, but that's okay. Alright, number three. GH plus HD equals FE plus ED, and we're adding on both sides, so that's why it's the addition property. Okay, number four, we have GH plus HD equals GD, so this piece of the line plus this piece of the line equals the entire line, and then we do the same thing over here. FE plus ED equals FD. And that, whenever we have pieces of a line that we're adding together to show the whole line, that's always the segment addition postulate. Alright, so let's see, we got congruence and segment addition postulate. Okay, number five. GD is equal to FD. So we had all this stuff up here, but we end up with just GD equals FD. So we actually substituted. And then finally, and again, let's notice, GD is equal to FD. GD is congruent to FD by the definition of congruence. Okay. Now let's go down here to our guided notes and adjust a little bit. There we go. Sorry. Okay. A protractor is used to measure angles. The protractor postulate it illustrates the relationship between angle measures and real numbers. You will use these theorems and postulates to find angle measures. So postulate 3.10, protractor postulate. Every angle has a measure that is between 0 and 180 degrees. So let's look at this protractor. So we go from 0 to 180 degrees. That's why it's called the protractor postulate, because that's how far we measure angles, from 0 to 180. Straight line is 180 degrees. every angle measures between 0 and 180. All right, postulate 3.11 says angle addition postulate. So D is in the interior of ABC, of angle ABC, if and only if the measure of ABD plus DBC equals ABC. So let me just show this here. So we have angle ABC. And they're saying that D is in the interior. Remember, we talked about the angles. This is the interior, the inside. So if D is here, we draw a line. They're saying D is on the interior if and only if ABD, so this angle, plus DBC, this angle, equals ABC. So D is only in the interior if those two angles equal the whole angle. Alright, theorem 3.3 is the supplement theorem. If two angles form a linear pair, then they are supplementary angles. So, see this line here. Well, let's say that we have a line going off of that to create two angles. Remember, this line, the whole line is 180 degrees. So, these two angles are a linear pair. If they form a linear pair, and they do, then they're supplementary. Supplementary means what? It's equal to 180. And these two angles together equal 180. And then lastly, theorem 3.4 is complement theorem. It says if the non-common sides of two adjacent angles form a right angle, then the angles are complementary angles. So let's see if we've got enough room to see me down here. So say we've got a right angle. The non-common sides of two adjacent angles form a right angle. So let's do this. So remember, our right angle, we have our box there. Then the angles are complementary. This is 1, this is 2. Notice they both together make a 90-degree angle. So in this case, 1 and angle 2 equal 90 degrees, or they're complementary. Okay. Flip over page 7. I'll go back and do a little normal math for a minute. Alright, so number 1, page 7. What is the measure of angle 3? So this is angle 3 over here. If the measure of angle 1 is 23 degrees, I'm just going to put 23 degrees right here for angle 1, and the measure of angle ABC, so the whole thing is 131. Well, notice first, so the measure of angle ABC is going to be equal to the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3. 1, 2, 3. Make the whole thing. Okay? Hope you guys have already noticed this, but just in case you haven't, angle 2 has the box. What does the box mean? The box means that angle 2 is 90 degrees. That's a right angle in the middle. So we're looking for 3. So if ABC equals the measure of angle 1 plus 2 plus 3, let's just substitute. So we know ABC is 131. We know the measure of angle 1 is 23 degrees. Okay, the measure of angle 2 is 90 plus the angle 3, we don't know that, so we're going to call it x. 90 plus 23 is 113. We're going to subtract 113 from both sides. Excuse me 1 second. Okay, sorry. Alright, so 131 minus 113 is 18. So x equals 18, or the measure of angle 3 is 18 degrees. Okay? Alright, number 2 is a you-do. Please pause here, work the problem, and then unpause. We'll see how we did together. Alright, number 2. What is the measure of angle 3 if angle 2 is 26 degrees. Alright, well, I hope you guys first noticed the box here. So that means angle 1 is 90 degrees. Angle 2 is 26. So all three of these, well, didn't give us a total. Oh, that's right. All three of these angles are on a line. So all three of these guys together, I'm just going to color it like this. All three of those are a linear, they're not a pair because it's not 2, it's 3, but they make a straight line, so all three of these together equal 180. So when we go to solve this, that's why it didn't give us a total, because it wanted us to know that this line is worth 180. So all three of these angles are worth 180. So 180 equals a measure of angle 1, 2, and 3. I don't have to write that out again, you guys know. So 90 was 1, 26 was 2, and we don't have 3, so we're going to call it x. Okay, so 90 plus 26 is 116. Subtract the 116 from both sides. 180 minus 116 is 64. So the measure of angle 3 is 64 degrees. Let's go down here, look at number 3 and number 4. Both of these are asking for the value of x. You'll notice these are the same figures from above. So I'm going to go ahead and mark our 90 here. Oops, 90 degrees. Our 90 here. Let's see. So over here, what is the value of x if the measure of angle 3 is 6x? So we're going to call it 6x this time instead of x. We called it x the first time. But the whole total is 131 again. Let's see. They told us that 1 was 23 degrees. So angle 1 plus angle 2 is 90, plus angle 3 is 6x. Okay? 90 plus 23 is 113. We're going to subtract 113 again. This time 6x equals 18. So we're going to divide both sides by 6. X is going to equal 3. Notice the first time it was 18. This time they changed x to 6x. All we did was divide it by 6. And 18 divided by 6 is 3. So that's why it was 3x. But if you multiply, if you were to say, okay, well, what's the measure of angle 3? 6 times 3 is 18. That's what it was in the first problem. All right, number 4 is another you do. Please pause here, work the problem, and then unpause and see how you did. I'm going to wait 3 seconds. All right, number 4. What is the value of x if the measure of angle 3 is 2x plus 4, if the measure of angle 2 is 26 degrees? Okay, so again, same figure. So this is a straight line. These three equal 180. So 180 equals measure of angle 1, 90, plus the measure of angle 2, 26, plus the measure of angle 3, this time 2x plus 4. Alright, so 90 plus 26 is 116, plus 4 makes 120. So then we subtract both sides by that 120. 180 minus 120 is 60. It's equal to 2x. Divide both sides by 2, and x is going to equal 30. Okay. Just a moment to adjust. Okay. All right, guided notes, bottom of page 7. The properties of algebra that apply to the congruence of segments and the equality of their measures also hold true for the congruence of angles and the equality of their measures. All right, so theorem 3.5 is the properties of angle congruence. So first we have the reflexive property. I'm just going to go ahead and highlight all three of these. Now, reflexive, as I've said many times in class, if you look in the mirror, you see your reflection. So the reflexive property is saying that angle 1 is congruent to itself. And I kind of showed some of you guys, but later on we're going to have triangles that, there's two triangles and they come together from a common side. So that side, we'll call it AB. AB is congruent to itself because it belongs to both triangles. But for now, we just need to know that this angle is congruent to itself, and that's reflexive. Symmetric says that if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. Just flip-flop it. Okay, and then transitive is talking about all three. It says that if 1 is congruent to 2, and 2 is congruent to 3, then 3 and 1 have to be congruent. Okay, let's flip over here. We're going to move on to page 8. Okay, page 8. Got some more theorems. Theorem 3.6 is the congruent supplements theorem. So angles supplementary to the same angle or to congruent angles are congruent. The abbreviation here is angles supplementary to the same angle or congruent angles are congruent. So like in the example over here, you have angles 1, 2, and 3. It says if the angle 1 and angle 2 equal 180, and angle 2 and angle 3 equal 180, then 1 and 3 have to be congruent. So just as an example here, let's say that angle 2 is 100 degrees, okay? They say 1 and 2 are 180. All right, so if 2 is 100, then 1 has to be 80, okay? Well, we're going to look over here at 2 and 3. If they're both supplementary and 2 is 100, then 3 has to be 80. Hopefully that helps make a little more sense. All right, so theorem 3.7 is the congruent complements theorem. It says that angles complementary to the same angle or to congruent angles are congruent. Abbreviations are down here below. Angles complementary to the same angle or congruent angles are congruent. So like over here, it says that if angle 4 and angle 5 are complementary or equal 90, hopefully you knew that already, and if 5 and 6 are complementary, then 4 and 6 have to equal. So let's say that angle 5 here is 50 degrees. Well, if angle 4 and 5 equal 90, and angle 5 equals 50, then angle 4 has to equal 40. Same thing over here. If 5 and 6 together equal 90, and we already know that 5 is 50, then 6 has to be 40 also, which makes 4 and 6 congruent, like it said. All right, I'm going to scoot this page up just a little because I'm hanging off the table here. All right, theorem 3.8, vertical angles theorem. If two angles are vertical angles, then they are congruent. Well, we already know this because we've talked about vertical angles quite a bit. So these are two lines that intersect. They make four angles. 1 and 3 are going to be congruent to each other. 2 and 4 are congruent to each other. Basically, if they are beside each other or on top of each other, they are congruent. Alright, have another proof. Middle of page 8. Write a paragraph proof. This is number 5. Given that angle 1 and angle 3 are supplementary. So it says given blank. Well, there you go. Angle 1, angle 3 are supplementary. Not enough space, but there we go. Alright, so these two are supplementary. By definition of a linear pair, blank are a linear pair. Well, these two right here are both riding the same line, angle 1 and angle 2. So it's angle 1 and angle 2 are a linear pair. If they're a linear pair, second. Yes, just making sure. Then if they're a linear pair, then angle 1 and angle 2 are also supplementary. We're going to run out of space. Okay. So by the blank theorem, angle 2 is congruent to angle 3 because they're both supplementary with angle 1. And that's what we just talked about up above. That would be theorem 3.6. I'm going to write theorem 3.6 here, but under it, we're going to write it's the congruent supplements theorem. Okay. Let me adjust here. All right, bottom of page 8. You can prove the following theorems about right angles using what you already know about angle measures. So theorem 3.9 says that perpendicular lines intersect to form 4 right angles. So if these two lines are perpendicular, I'll do this in blue. So this would be a 90-degree angle, but so would this, so would this, and so would this. So we end up with 4 90-degree angles, and if they're all 90 degree, they're also congruent. So I'm telling you all this stuff. Spoiler alert, it's in the theorems here. All right, so 3.10 says all right angles are congruent. So if a right angle equals 90, they all equal 90 because that's the definition. So they're all congruent. 3.11, perpendicular lines form congruent adjacent angles. Adjacent means next to. So this guy and this guy, or this guy and this guy, or this guy and this guy. Either way. So yeah, the angles next to each other on perpendicular lines are all congruent because it's 4 right angles. Theorem 3.12 says if 2 angles are congruent and supplementary, then each angle is a right angle. All right, so as your math teacher, it's my job to tell you if you take 180 and you divide it by 2, you're going to always get 90. And if 90 is a right angle, it would take 2 of them being congruent, so both are 90, to be supplementary. You can only divide 180 by 2 and get one answer, and it's 90. Okay, theorem 3.13. If 2 congruent angles form a linear pair, then they're right angles. So notice, let's see if I can make this work. So notice each side of the line. That's a linear pair. Scoot it up. There we go. That's a linear pair, and they're both 90. They equal 180. So again, this is all because these 2 lines are perpendicular. Forms 4 right angles. They're going to be congruent. We're going to go to page 9 now. Okay, page 9. All right, number 7. Let me just back up a little bit. I would like you to see the word bank in there at the same time. All right, number 7. In the figure, ABE and angle DBC are right angles. So notice here, ABE, so ABE, that's a right angle. And then this other one has a box, DBC. So the box, for the red box, is these 2 angles. Let me see if I can just kind of shade it a little red. So these 2 are red, but the problem is that the blue is going to kind of overlap. So the blue is here, and it goes into here. So these 2 angles, and then these 2 angles. It's 3 angles, but the one in the middle goes with both. Okay, so our given, angle ABE and DBC are right angles. So that's our first statement. It's given. So given is our reason. Number 2, the measure of ABE and the measure of DBC is 90 degrees. So my choices are definition of complementary. Well, that's two angles that equal 90. These are two angles that equal 90 each. Congruent complements? No. Definition of a right angle, or right angles. Yes. The definition of a right angle or right angles is they equal 90. So definition of right angles. Okay. Number 3. ABD, angle ABD and DBE are complementary. DBE and EBC are complementary. Let's see what we got here. And that's the definition of complementary. They both equal 90. And then lastly, angle ABD is congruent to angle DEBC. And that's your congruent complements theorem. I think we may have gotten that backwards, but we're going to go with it. I believe that's what the book had. Alright, number 8 is a you-do. So please pause here. Try to work this proof yourself. I'm going to wait 3 seconds and then continue. So unpause once you're done. Let's see how you did. Alright, number 8. Write a proof. So tell us that 1 and 2 are congruent. So angle 1 and angle 2 are congruent. First statement, 1 is congruent to 2. That was given to us. Okay. Number 2 says that angles 1 and 3 are congruent, and 2 is congruent to 4. Notice here we have the two lines that intersect. So in this case, let's see, we'll do 2. So 1 and 3 are congruent to each other, and we'll do 3 since that's hard to write with a crayon. So 2 and 4 are congruent, and 1 and 3 are congruent, and that's because they're vertical angles. Okay. Number 3 says that 3 is congruent to 1. Up here we had 1 to 3, 3 to 1. That's symmetric. When we were just taking the equation and just flip-flopping what's on each side of the equal sign, that's symmetric. The symmetric property of equality. Alright, number 4 says that 3 is congruent to 2. Now we're adding in a third angle here, so that's transitive. And then we have a fourth that's still transitive. And that was the last 2 choices left anyway. But we just used what we knew. So if you look, we already knew that 1 and 3 and 2 and 4 were congruent. Once they made 1 and 2 congruent, they're all congruent. And that's what most proofs end up doing. You end up touching every angle or every line segment or every piece of whatever shape we're looking at. Alright, let's flip over to page 10 and finish off this packet. This will be the end of week 6 packet. With the impending hurricane, we are going to wait until Monday to begin the week 7 packet, but it works out. We were a little bit ahead anyway, and week 7 starts next week, so it works out. So page 10. Top of the page there we have a I do and a you do. The I do's on the left, so let's look at it first. Write a proof. Look again, we have more vertical angles. The given is that 1 and 4 are congruent. So this looks very similar to what we just had. The 1 and 4 are congruent. Well, we can see that 1 and 3 are congruent because they're vertical angles that way. And 2 and 4 are congruent because they're vertical angles in that direction. And that's going to halfway answer our proof here. But 1 and 4 was our given. 2 and 4. Let's see. Yeah, so 2 and 4 are vertical angles. Alright. Statement 3 is 4 is congruent to 2. Well, 2 is congruent to 4. We just flip-flopped our equation, so that's the symmetric property. Alright, now we have 1 is congruent to 2. And that's transitive property, because now we've added in a third angle. Angles 1 and 2 are a linear pair. And that's the definition of a linear pair, that they're on the same line. And then finally, number 6, angles 1 and 2 are right angles, and that's going to be theorem 3.12, which was on page 8, I believe. Let me look back. Let's see. Yes, page 8, theorem 3.12. If two angles are congruent and supplementary, then each angle is a right angle. So 1 and 2 are right angles because they're a linear pair, because they're congruent. They have to equal up to 90. Alright. You do. Please pause the video, work this proof, unpause and see how you did. You gotta wait 3 seconds. Alright, you do. Page 10, last problem on this packet. Complete the proof. Given is that lines J and K, so this line and this line, are perpendicular. Well, if these two lines are perpendicular, then angle 1 and angle 2 are both 90 degrees. Alright, and they're telling us also that angle 1 is congruent to angle 4. So we have two givens here. Just keep that in mind. Alright, so number 1 says lines J and K are perpendicular. That was one of our given statements. Number 2 says that angle 2 is congruent to angle 1. Well, that is going to be theorem 3.11. If we go back to page 8 again, perpendicular lines form congruent adjacent angles. These guys are congruent and adjacent or next to each other, so they both equal 90. So that is why it's theorem 3.11. Okay, 1 and 4 are congruent. That was our other given statement. And then 2 and 4 are congruent. Well, if 1 and 2 are congruent and 1 and 4 are congruent, then by the transitive property, 2 and 4 have to be congruent. If you have any questions, let me know in class. This finishes up this packet. You guys have a great evening.